In this video, I'm going to explain you the very important concept in embedded C, that is nothing but the function pointer. Function pointer is a very important concept. In this video, I'm going to show you the actual source code where we use the function pointer. One is the Baremetal code from Google, that's on the embedded cell code. The second one is the RTOS code from the FreeRTOS, and the third one is the Linux kernel code. And here I will show you that how I use this source code of the function pointer to create my own device driver. So altogether it is going to be a very interesting video, so stay tuned. So see, this is how we define a function pointer, and the fun ptr is a function pointer taking two integer argument and returning a characters. So if you want to assign some new function to it, like you can simply like that, and then or simply assign foo2 function, foo3 function, right? Now there's another way you can use the function pointer concept, like you can define a new data type of the function pointer. The same thing you can define here, and then you cannot use the same thing to assign any function address to the function pointer, because this now this one fun pto become is a new function type, function pointer type basically. Now you have to create a variable of this, like fun ptr fun ptr where one fpto, and as well as where two f function function pointer. Now you can store this foo3 function here. All right, we will see all these things we'll see all these things in that source code. So let's start with the function pointer. So here read character is a function pointers, which is taking nothing and returning integers, and write character is a function pointer, which is taking this character as an input and returning nothing. Now if you see this set read character function is taking means taking input a new function and then assigning the address of the function to this read character. Alright, similarly set write character function is taking an input of a function having the defined type which is taking characters input and returning nothing, and assigning the address of the function to the right character. So the next time onwards, whenever this read character, the right character function will get called, it will call the respective function which they are pointing to. So when they are getting called, here you can see in the delete function, the right character function is getting called with this with this argument backspace of space. So eventually it will end up calling this function which is referring, which it is storing which it is referring to with the given argument. All right, so this is an example of function pointer in Baremetal code created by the Google. As well as if you see some so here you can see this is a pointer to the cmd struct type. So here what we're storing the address of start address of some cmd table, and as you know, this is just an address, so we just need to typecast it. So this is what they did. They first take that variables address value, and then they just typecast it in the cmd type. So similarly they did it for that autoload pointed to this cmd type. They take that address and then they take that address and they simply typecast it, otherwise it won't be able to store it. So this is a beautiful example where address of void pointer type is getting typecasted to the respective start type based on the variable pointer variable it is getting stored. Apart from that, if I see this in weak attribute, so it is a beautiful use case of the weak attribute. So when a function, this function is defined with the weak attribute, it means its actual definition is defined somewhere. If the actual definition is not there, then you can use this fun when some function is someone is getting calling this API setup. If it is not defined somewhere, then it will call this API, else it will call the actual API where it is implemented somewhere. So in the platform.c file, you can see this setup function is implemented here. So whenever there's an API call, it will call this setup functions. Okay, even though it's not a function pointer concept, but I feel like the weak attribute use case is important here. All right, now let's jump into the function pointer in the FreeRTOS code. So first thing first, okay, all right. So you can see this is a structure x task parameters, which is having a couple of members here. If I see the second member, the PC name is a pointer to the constant character. So this is a pointer data type, uh, pointer data pointing to character data type, and this is a function pointer. Now you might get confused why I'm saying this is a function pointer. All right, now just like here while explaining you here, I have defined that we can define the function pointer with the type def, where this will define a new function pointer type and we need to create a variable of it. Similar things they have used here. So yeah, so you can see this type task function pointer task function underscore t is a function pointer which is taking one argument of white pointer type and returning nothing. Now it is defined with the type def word, so next time they have to create a variable of this type and then only they can use it, right? Similar thing is happening with the ubase type t and the stack type t. Also, this is a beautiful use case of the function pointer in the FreeRTOS code. And one thing that I can feel in the FreeRTOS code, they're trying to inherit the object-oriented programming paradigm, because see, this is, you can consider as a class. It is having some set of members, having data members. This is kind of data acting as a data member, and these are the functions. I mean, function pointer referring to a function, of course. So ultimately, they are the functions. So they are all together, integrating all the data member as well as the function member in one structure. So it is a beautiful example of how in the FreeRTOS code they are trying to inherit, or they're trying to replicate the object-oriented programming paradigm, right? Even though C is not an object-oriented programming language. All right, now let's jump into to this Linux code. It's a file system.h header file. Here also they have defined a file operation structures with a couple of functions as well as data member. See, this is a pointer of pointing to start module type, and the second one itself is a function pointers taking to a, I think, yeah, 3 argument and returning this data type L of t, which is defining the Linux kernel, of course. And similarly, read function pointers having some sort of taking some sort of input and returning this size t. The size t mostly an unsigned integer or an integer. I need to check it out. Now here again you can see this is a structure having set of functions and some data members trying to replicate the object-oriented programming. What I did, I used this files operations to create my own character device driver. I called it PCD driver, pseudo character device driver, and then I will show you how we use this function pointer to point to the function defined by me. So here, this is the code of my character device driver. Here you can see PCD read is defined by me, PCD lseek is defined by me, then PCD write is defined by me, as well as PCD open is defined by me. All right, now also PCD release. Now if I see here in the struct file operation, I'm defining a variable where for each function pointer I am storing the address of the function, user defined function, right? This is the function I defined. So I'm storing the address of in the write PCD write, in the read PCD read, in the release PCD release, and in the open in the PCD open. And this honor modules, you can see this honor modules is also pointed to the structure module type. Here I'm showing this module means the current driver modules address, right? So you can see how I use the Linux source code file operations structure to create my own device driver. And here I simply use this function pointer beautifully, and all the point concept boils down to the point, like, if you know this part, if you know this part, then this is more than sufficient. This is more than sufficient to understand any of the, bare metal code or FreeRTOS code or Linux source code very easily. And thank you for being such a wonderful audience. Please feel free to, mention which topics you want to see, which topic I should cover for your easy understanding. I want to make the embedded, community concept very easier, so that everyone can grab the concept and become a good embedded software engineer. So thank you very much for staying with me. Thank you. Bye bye.